Next presentation. It's from Dr. Sanjay Adiwal. The title of the presentation is Leveraging Open Source IDS in Cloud Environments, a case study on enhancing security and threat detection. Over to you, Nick.
Thank you. Yeah, thank you. So I am Dr. Sanjay Adiwal. Along with me, Dr. Misbauddin Mohammed. So we have worked on this research work, where we just wanted to know whether the SNOT can be used to, provide security for the cloud infrastructure or not. So this is the outline of the session. Now, if you see the objective here, the internet world has grown exponentially in past 2 decades. So you see your daily activities of human are now heavily dependent onto the internet and IT. Again, the large number of data and sensitive informations invariably being communicated over the internet, and especially through the cloud infrastructure. And we have more and more security loopholes and vulnerabilities related to cloud. And hacker can use a lot of vulnerabilities on the cloud, and they can try to access a lot of services on the cloud. Now, if you see here, the internet of 2022, there are 305 billions of emails are sent daily. And again, around 5 billions of users are there which is connected onto internet. And if you see on Google, there are 3.5 billions of searches are happening per day. And 1 trillion of unique URLs are currently available onto the internet. And internet pen testing estimated around 59 to 60%. And you see on YouTube, daily 5 billions of videos are viewed. And our 14% of global trade is happening via internet. So internet is actually core of our daily life. Now, if you see the current trends and challenges in cloud security, we got the increased adoption of cloud services. So more and more organizations are moving the data and application onto the cloud, that we know. And which means there are more targets for the cyber criminal to the attacks. Again, more sophisticated attacks are there, like we have ransomware, we have data breaches and all. Recently, last year, December, we had the AIMS attack, which is nothing through ransomware it has happened, and 5 server got damaged actually, the data got lost. Again, we have the supply chain security, where the cloud providers rely on third-party vendors to provide services, which can lead to potential security vulnerabilities if the vendors are not securing their infrastructure. And finally, we have some insider threats. The employees or contractor which with access to sensitive data can pose a security risk if their credentials are compromised, or even they are actually misusing it. Now, to address these challenges, the cloud service providers are investing in security measures such as encryption, identity and access management, network security, and regular security assessment like VAPT or cyber security audits. Again, they are depending on IDS, IPS, and other solutions. So the motivation to this research work is to measure the effectiveness of the existing open source IDS, which is SNOT, for securing the cloud infrastructure. Now, these are the 3 pillars of cyber security. We all know we have confidentiality, we have integrity, we have availability. Now, let us move here on to IDS. What is IDS? It is an appliance, any hardware appliance or any software application which is used to monitor the network or any system for the malicious activities, right? And alerts will be sent to the user. Now, we have different types of IDS. We have network-based IDS, we have host-based IDS, we have offline, online IDS and all. And these are the list of open source IDS which is available here for the use for the cloud security. We have Bro, we have SNOT, we have OSSEC, Surikata, Security Onion. Among these, SNOT is one of the most used IDS across the world. So what are the various types of IDS classifications? So there are 3 categories based on deployment of the IDS. So where you're deploying on the network, or you're deploying on the host, even if you're deploying on the application. Then you have based on the type of the IDS or the detection type, whether it is a known database which is called signature based or behavioral based. And third category here is what? Based on the response, whether it is active IDS, or passive IDS. Active means your IPS, intrusion prevention system. Now, where the IDS solution is currently deployed and how it can be deployed on the cloud infrastructure, let us try to discuss. This is the scenario here. So we know that we have the host-based IDS, we have the network-based IDS, right? So the IDS can be deployed as a host in the network. Network also, if you see, after your router, it can be deployed. After your firewall also, it can be deployed. Even your wireless network, it can be deployed. The same thing applies in the cloud also. So if you have a cloud running somewhere, before cloud, the IDS has to be deployed. Now let us discuss the signatures of the IDS. So we have two categories here in the IDS signature. We have first category is the signature header. So header will contain what? It will contain the action, means whether you want to alert or you want to block, protocol, source port, destination port, and so on. Whereas in the signature part, message which has to be given as alert will be mentioned here, and the pattern which you are searching, which will be specified here, along with some modifier keywords, meaning the pattern what you exactly want to search. And then we have signature ID and revision. Now, this figure shows our experiment setup, what we have done here. So here, what we have done, we have established OpenStack cloud, and we use two servers. One server is controller node, and the second server is compute node. And in these two servers, actually, the OpenStack, two VMs we are using, which is called one a vulnerable XP machine, and second is Metasploitable 2. And this cloud is connected to our LAN, and then it is protected by a SNOT IDS, which actually we have deployed on Ubuntu 22.04. And it is SNOT 2.9 what we are using here. Then we have attacker's machine. So attacker machine is in the LAN as well as in the internet also. Now, the evaluation of the SNOT setup has been accomplished on sophisticated assessment by conducting various attacks. So we have performed various attacks. You can see three categories of attack what we have performed here using Kali Linux is the attacker's machine, scanning, DOS, and email bombing attack, which is there on the vulnerable XP machine. So this is the scanning attack what we have performed here. So this is the IP address of one of the vulnerable machine in the OpenStack cloud. It is an instance of the OpenStack cloud. And once we are running this scanning, you see that the SNOT is successfully detecting this kind of attack. Okay. Now, second attack is what? DOS attack. Using HPing tool, we have performed this attack. And again, the same machine, which is a vulnerable XP machine, there we performed this attack. And you see that here also, the SNOT is able to detect the attack very successfully. Third is email bombing attack. So here again, we used a Python SCAPI module to form one packet for sending an email bomb attack. So this is the command what we have used, and we saw that the SNOT is successfully detecting this particular attack. Apart from these attacks, what we have done actually, as I told you, we have one more virtual machine in OpenStack Cloud, which is called Metasploitable 2. And on that also, we have performed so many attacks. Those three attacks what we have performed. Number one is web application attack. So here actually we are using Slow Loris tool, and we have performed the attack which is called DOS attack using this tool. And second is VSFTP attack. So this is the one vulnerable FTP server was running on this Metasploitable 2. There also we perform attack using Metasploit framework. And then we performed one more attack called MySQL. And SNOT was successfully able to detect all those attacks. So this is the conclusion. So what we conclude here, that SNOT is very much useful, or any open source IDS is very much useful in the cloud security also. So it has to be deployed in your network. So these are the references which I used. Any questions, queries are welcome.